Javier walks from his house to the zoo at a constant rate. After walking 75 hundredths of a mile, he meets his brother Raul and they continue walking at the same constant rate. When they arrive at the zoo, Javier has walked for half an hour and Raul has walked for 2/10 of an hour. What is the rate in miles per hour at which the brothers walked to the zoo? So the rate in miles per hour is the thing that we need to know. So when we define our variables, that's going to be it. R is the rate in miles per hour they walked. Okay, so Javier clearly lives farther from the zoo than Raul. So if we were going to draw a picture, we would have Javier's house. Then he walks to Raul's house, and then both of them walk to what would a zoo look like? I'm just going to draw a zoo like a house. We're going to say this is the animal's house. Okay, so it says Javier walks for 0.75 miles and he meets Raul. Actually, it doesn't say that he meets Raul at his house, but we'll just assume he does. He meets Raul somewhere. And when they arrive at the zoo, Javier has walked for half an hour and Raul has walked for zero point 0.2 hours. So from Javier's house to the zoo, oh, I probably shouldn't use the same color. Change colors there. From Javier's house to the zoo, he walks for half an hour. And from wherever Raul was to the zoo is zero point 0.2 hours. Okay. So we need to come up with an equation for Javier, an equation for Raul, and then we're going to set them equal to each other because we know that they both ended up in the same spot at the zoo. Okay, so um, the equation for Javier is going to include that he walked more than Raul did. How much more did he walk than Raul? Well, he walked 0.75 miles more than Raul. So he walked 0.75 miles and then he walked more. How much more did he walk than Raul? Well, Raul walked for zero point 0.2 hours and Javier walked for zero point 0.5 hours. So Javier's entire travel time of zero point 0.5 hours is the same as Raul's zero point 0.2 hours plus 0.75 miles. Let me see if I can highlight this on the diagram. So Javier did half an hour, and that was the same as 0.75 miles and Raul's zero point 0.2 hours. See how those two highlighted lines are the same? The yellow highlighted line and the red highlighted line cover the same amount. So the 0.75 added to the zero point 0.2 times how many hours it was, or sorry, zero point 0.2 times whatever the rate was, is equal to Javier's half an hour times whatever the rate was. Now I know this can be a little tricky because you're like, wait a second. Javier is the one who walked 0.75 miles. Why is that on Raul's side of the equation? And that's why it's important to draw a diagram. When you draw a diagram, you see that the top part of the diagram, Raul's, or sorry, Javier's zero point 0.5 hours, that line going from Javier's house to the animal house, that zero point 0.5 hours is the same length as the 0.75 miles to Raul's house plus the zero point 0.2 hours that Raul walked. Those two highlighted lines are the same amount. So when we put the equal sign between them, one side of the equal sign has the zero point 0.5 hours, and the other side of the equal sign has the 0.75 miles plus zero point 0.2 hours. So that's why the 0.75 goes on Raul's side of the equation. Because to make the two lines equal, Raul gets the We have to include the 0.75 miles between Javier's house and Raul's house to make the distances equal. I hope that makes sense. It's why it's important to draw a diagram so that you can see what it takes for those two to be equal. Now that we have this drawn, our goal is pretty clear. If we want to get the variables on the same side, you can, just like we did with the fraction problem, you can work this with decimals. If you're like, I ain't afraid no decimals. I'm just gonna work it just like this with the decimals. No problem. I got a calculator, I'm good to go. That's fine. But just like the problem with the fractions, we can also solve this by turning all of the decimals into whole numbers. Turning decimals into whole numbers is much easier than turning fractions into whole numbers because to turn a decimal into a whole number, all we have to do is just move the decimal point over a certain number of spots. What I notice is that the decimal that needs to be moved the farthest is this one with the 0.75. If I moved this decimal over two times, that 0.75 would turn into a 75. I moved these decimals over two times, they would clearly be whole numbers. So I need to move all of these decimals over two times. And the way that we do that is we multiply everything by 100. Multiplying by 100 moves all of the decimals to places. So we do 0.75, and we're going to multiply by 100. Now this step that I'm writing right here is a step that probably at some point in your life you will be able to skip. You could probably just rewrite it with the new numbers, but I'm just for the sake of completeness, I'm going to go ahead and write it in here. You're like, why is he writing times 100? Why doesn't he just write it with the decimals moved? I want to be thorough. So 0.75 times 100 is 75. 0.2r times 100, well, 0.2 times 100 is 20. So this is 20r equals, and zero point 0.5 times 100 is 50. So 50r. Now we can get our variables on the same side. We can subtract 50r on both sides, but I don't recommend it for two reasons. Number one, if we subtracted 50r on both sides, we would end up with a negative. 20r minus 50r would give us negative 30r. And number two, we'd end up with 0 over on the right side. We'd have equals 0, which I don't love. It's not a problem. We can still solve it. I just don't love making the problem more challenging than I need to. So let's subtract 20r just to make life as easy on ourselves as possible. Why make it more difficult? We don't get extra points for making things harder. Math is challenging enough without trying to make life more difficult for ourselves. So now let's divide everything by 30. You may want to do 75 divided by 30 on a calculator, no shame. 75 divided by 30 comes out to be 2.5. It's not bad, but it's fine to use a calculator. 2.5 is the answer, but let's write our answer in context. 2.5 what? Well, we defined our 2.5 as the rate in miles per hour that we walked. So they walked at an average speed of 2.5 miles per hour. And now, if we really want to impress everybody, we can say how far away the zoo was. We can take one of their equations, either Javier's zero point 0.5 or Raul's 0.75 plus zero point 0.2r, and we can plug in the 2.5. So let's just use Javier's just because it's easier, like that. And that will tell us how far away the zoo is. I don't have a calculator handy, so let's do this old school. So the zoo is 1.25 miles away. And the problem didn't ask us how far away the zoo is, but why not go the extra mile and give them a little bit of extra information they didn't ask for? They walked an average speed of 2.5 miles per hour. It's 2.5 miles away. Oops, better not say 2.5 miles away from Pierre's house. It's only half a mile away from Raul's house. There we go.